And yeah, the last and most important point, while designing a recursive function, yeah, this is what we've been seeing throughout the session, but again, at the cost of repeating myself, identify the base and recursive cases. Again, how to go about this? If it is a sequence type question, look at the independent and dependent terms. Or if you are able to write the same code in an iterative fashion, write it that way and identify where your loop begins, where it ends, how it progresses from beginning to end, and try to write a corresponding conditions for a recursive code. Otherwise, try taking examples of all possible cases and identify the base and recurring conditions. So, for instance, this question asks you to find the greatest common divisor of a comma b, assuming a is always greater than equal to b, and as a hint, they have given you something which looks like a recurrence relation, b comma a mod b. So this looks very clearly like the recursive statement. So a comma b becomes b comma a mod b. This is just my recursive statement. I can copy paste this, but I don't know where my base case ends. And let's say mathematically or logically thinking, I'm not able to find out. So this is a GCD question. So you take two numbers as input. The only possibilities are either they are co-prime numbers, meaning their GCD is 1, they don't have any common factors, or they have a common factor, something like 2 and 8 for example. So those are the only two possibilities, right? So if you are not able to figure out something analytically, take examples of both possible cases. So this is a case where there is a GCD which is not 1. This is a case where they are co-prime. So take these two, work out the function stack. So 10 comma 2 becomes 2 comma 0, and then GCD of 2 comma 0 will be 2. I'm sorry. Similarly, 9 comma 2 will be 2 comma 1, and then yeah, so you work out the stack, or you work out how the recursive function calls go. So you will notice that for this example, the base case is always attained when this second term becomes 0 finally, and at that case the first term becomes the GCD. So my point being, if you are not able to identify the base or recursive condition through logic or by looking at the series, take examples for every possible condition that can arise and write them down. Identify what is common among all those examples. That will give you an insight about the base and recursive conditions. And then identify what variable should be used. As in, if it is a sum, I'll initialize s as 0. If it's a factorial question, I'll initialize f equals 1. That kind of stuff. Identify if the function should print or return, and design the algorithm appropriately. That again, we looked at what is the difference between print and return. And the final thing, recursive function may be of different formats. One is you have a base case, and then in the recurring case you have a computation and then something that leads to the base. Example will be the base case you simply return. Recurring case there is a no, wait, I'll give a different example. Yeah, here. Base case, you are simply printing. Recurring case, first there is a line of computation and then something that leads you closer to the base. That is one format. Second one, there is some common computation irrespective of whether it is base or recurring, and then base asks you to do something, recurring is simply leading you to the base. This is an example. This computation happens for every factor irrespective of whether it's the base or a recurrent case. And then base case, you are asked to return something, recurring case is leading you to the closer to the base case. So there are multiple formats. So it is not like base will always have only one statement, recurring will always have two statements where one is a computation, the other is a function call. It's not necessary. Recurring function is just one that calls itself. It can be designed in any of these ways, and it depends totally on what your problem asks you to do. So the idea is, when you read the question, understand all these 5 parameters, understand what the question expects from you in terms of these 5 parameters, and then code accordingly.